Welcome back all the fans and followers of space fiction. I believe that many of you have already started building your own space station, haven't you? However, you will definitely encounter one technical problem during construction, and that is the elevator. I don't mean the elevator between two floors in the outer ring of the station. In a sufficiently large rotating space station with artificial gravity, you can use a standard system with rope and one counterweight. But if spaceships will dock to the central module, it will be necessary to create a system for moving material into the station's ring. And you will find out very quickly that it is not easy at all. Why? If you have an elevator in a house on Earth, then its move from the first floor to the highest one will be quite easy because of counterweight. The counterweight's weight helps the engine to pull the cabin up. And likewise, if the cabin is at the top floor, the Earth's gravity will ensure that the cabin can descend to the ground floor, and at the same time it will lift the counterweight all the way up. However, this is not possible on a rotating space station. If the cabin is at the bottom and the counterweight is up, the counterweight cannot help the engine lift the cabin up because there is almost no force acting on it. And vice versa as well. If the cabin is in the middle of the station, then almost no force pulls it down, and the elevator engine would not have enough force to lift the counterweight up. How to solve this problem? There are several solutions, although some of them are not very effective or are more demanding to maintain. A loop of rope could move an elevator with or without a counterweight. However, this would put an enormous strain on the engine, which would have to be able to not only lift a full cabin, but also hold the cabin on different floors and slow it down at the bottom, because there will be no balance of forces. Such an elevator could exist, but its parts would wear out very quickly and could break down very often. The second option is to build a climbing elevator without a rope and let it climb up by its own engine. It would also be possible, but again, all the weight would be transferred to the engine and its mechanical components. In the lower floors, it would have to fight with the biggest forces, and all the mechanical parts would have to face quite a big stress. And I'm not even talking about high electricity consumption for this type of elevator, which is quite a thing on every space station. Very effective and reliable would be an elevator based on the Paternoster principle. This type of elevator runs in an endless loop, and the main advantage is that the forces are always balanced on each floor. Paternoster as such is of course useless for a space station. However, if we use its loop system, if we leave only one cabin, and if we replace the other cabins with smaller counterweights, we get an ideal elevator for a rotating space station. In this case, the cabin will not go around in the loop. It will only move on one side of the loop. Only counterweights will go through the elevator drive system. The main task of these counterweights will be to establish a balance of forces. As a result, the engine does not have to exert much effort and will therefore not wear out much. So it will be quite efficient and reliable. The last type I would like to mention here is the hydraulic elevator. On Earth, these elevators work by supporting the cabin with a large piston that is raised up or pulled down using hydraulic fluid. But we do not have space under the cabin at the rotating space station. However, we have enough space for such a piston above the cabin. The hydraulic cylinder can be located on the opposite side of the rotating space station. In order to avoid a major change in the station's center of gravity, the tanks for the spent hydraulic fluid from the piston would have to be located parallel to the elevator shaft. On the way down, the fluid would be pumped into the piston, and on the way up, it would be pumped out of the piston out into the tank. Actually, there might be some other amazing solutions for a rotating space station elevator too, and if you have one, just let me know in the comment section below. And finally, one more important information. The forces that will act on you in the elevator in the rotating space station will be very surprising. On the way up, during acceleration, of course there will be a slight pressure on the floor, just like on Earth. However, along the way up, your gravity will gradually decrease. It won't be a zero as long as you are approaching the center at a constant speed. But no one can prepare you for what happens when the elevator slows down and stops in the middle of the rotating space station. Not only do you go into zero gravity for a moment, the braking force even throws you up to the ceiling of the cabin. And the same way from the center down to the station ring. That's why you should always stay buckled up in the elevator. If you want to become part of the world of space fiction and help me create interesting videos more often, subscribe to YouTube and support me on Patreon by clicking on the link in description. Thank you for watching, and the next time I fly by the Earth, I will send you another new video from the world of space fiction.